Okay, so this time we are starting our stats section, and so statistics is really nothing more than taking a lot of data and organizing it and presenting it in a way that allows us to get overviews and explanations without needing to look at the entire set of data. So, a couple different ways we can do that. One would be a frequency table. Graphs are another way to do it, bar graphs, pie charts, things like that. Um, and so, a couple of things we're going to look at is the distribution of the data set, and that's how the data is spread out over all of the values. And then we're also going to look at kind of the shape. And so, the first three things we're going to look at are hopefully three things that you remember from middle school, and that would be the mean, the median, and the mode. So the mean is usually called, more commonly called, the average. It's kind of the, if you will, the common term, the term that most people use, and it's probably also the most common one that is used. And so the mean is really just the sum of all the values divided by the total number of values. So I add up all the numbers and then divide by the number of values that we have. The median is the middle value. And in order to find the median, you need to put the numbers in order from smallest to largest and then find the middle one. If there happens to be a even number of values, then you take the two middle ones and then find the average between them. The mode, or is the most, some students like to associate them, is the most common value that shows up. All right, so a couple examples. First one, we have 8 energy bars, or the prices of 8 energy bars, and we want to find the mean, the median, and the mode. So for the mean, we just add them all up, $9, $29, $29, $35, so on and so forth. Add them all up, that gives us 11.28 or $11.28. Divide it by 8, since there was 8 values, and we end up with $1.24 is the mean value or the average value. To find the median, we're going to find the middle number, and in this case, since there was an even number, it's going to be halfway between $1.35 and $1.39. So we add them up, divide by 2, and the median value is $1.37. And the mode is the one that shows up the most. And there are 2 cases where there's $1.29. Everything else just has 1, so the mode is $1.29. All right. With the virus going on, everybody's probably had their body temperatures taken as you try to enter buildings and things like that. And so in this case, we have had body temperatures taken 9 times. They are recorded here, and we want to know the mean, the median, the mode of the body temperature. Now, in this case, just for the median, we do need to put them in order. I find it easier when you put them in order to cross them off so you don't miss one and you make sure you get them all in order. So 98.0 would be the first case. There are 4 cases of 98.4, 3 cases of 98.6, and then a 99.0. So to find the mean, we add them all up, and we get 886.4 divided by 9, and the average body temperature is 98.5 degrees. To find the median, since there's an odd number of temperatures, in this case 9, we're going to find the middle one. There's only one, and that would be 98.4. There was 4 values above it, 4 values below it, and then 1 value for the median. And then the mode, there was 3 cases at 98.6. There was 4 cases at 98.4. So therefore 98.4 would be the mode. That is the value that shows up the most. And If your teacher calls you average, I guess we are being mean. And same thing, the average of 3, 4, and 17 is 8. So technically the 8 is the mean one. And when people, on average, when people say average, they mean mean. You say average, you can also mean mediocre, or somewhere in the middle. And hopefully this doesn't happen very often, but if you add up the numbers, divide by how many numbers you've added up, you have the average amount of minutes you sleep each day in class. Hopefully that is close to 0. All right, one thing that we kind of want to keep an eye on is an outlier. And the outlier is a data value that is either much higher or much lower than the other values. So an outlier will change the mean, but will not affect the median very much and has no influence on the mode. So when people talk about average, sometimes the average could be a little bit misleading if you have a huge outlier. For example, if we are keeping track of the average basketball score for player scores 3, 4, and 5, we'll keep it simple. Add them all up, gives us 12. Divide by 3 gives us an average value of 4. 4 is also our median. But if on the next game they score, say, 40 points, well, 40 would be the outlier. It's a lot bigger than 3, 4, and 5. The median really just moved from 4 to 4.5, so not much of a change. But if I add 3, 4, 5, and 40, I get 52. Divide that by 4, I get 13. And so one value of an outlier changed our average scoring from 4 to 13. That's a pretty big jump. That's more than triple what they were normally doing, simply because they had one value that was an outlier. You may have hopefully never seen this, but some of you may have seen this when you're talking about test scores in class. You have 2 or 3 really good scores, and then you have one low score that's an outlier, and it drops your grade. That is because that one low score is an outlier, and it's affecting the mean, in this case in a negative way, and dragging the class average down. So kind of watch out for the outliers. The mode won't change. The median will change a little. The mean, however, changes a lot. All right, so here we have a basketball team. The one outlier in height is fairly obvious. Everybody else is about the same size. And so the coaches are deciding, do we scare the opposition by announcing the mean height, where that one kid, tall kid, is going to pull up the average height on the team? Or do we lull them into a false sense of security by announcing the median height, which really isn't going to change with the outlier? All right, so after the mean, the median, and the mode, we can also describe the distribution. So when we are describing our distribution, we want 3 things. We want to know the number of modes, is it symmetric or skewed, and the variation. So when we're working with general shapes, we usually do a smooth curve rather than the actual data. And so here are 3 kind of smooth curves. You can see the raw data underneath it, and then we just draw a very smooth curve to it. And when you're drawing the smooth curve, it's not going to fit the data exactly. Real world data does not make a perfect mathematical model. In fact, just the opposite. If you have a perfect mathematical model for the data, your data is fake. There's something wrong with the data. The real world doesn't work like that, so don't be concerned if you can't make it fit exactly. That's why it says general shape of distribution, Okay, we're just going to get an overview. We're not getting an exact match. So the modes, all we're looking for here is the peak. So A, we have one peak. B, there are two peaks. And C, there's also one peak. Okay, so in cases of A and C, there's one number that shows up a lot and everything else is kind of scattered. For B, there was two numbers that showed up a lot. All right, skewness or symmetric. If there is a vertical line in which you can fold the graph in half and have one side line up with the other, or once again fairly closely, okay, if it's not exact, we're okay with that. We want something very, very close though. Then we say it is symmetric. So A, B, and C are all symmetric. There's all a line of symmetry where if I was to fold the paper in half, the left side of the graph would line up with the right side. So A and B are symmetric with one mode. C is symmetric. It is trimodal, or has three peaks. Okay, but it's still symmetric. I can fold it in half and one side lines up with the other. If it is not symmetric, then it's going to be skew. It can be skewed to the left or it can be skewed to the right. Some students will confuse this. What you're looking for is whatever side the tail of the graph is on, that is the side that it is skewed. The tail shows you where the outliers are. Okay, so if it is left skewed, there are outliers to the left. If it's right skewed, there are outliers to the right. All right, so A is going to be skewed to the left. Notice we have a bunch of numbers on the higher end, the right side. And then as you go to the left, there are fewer and fewer numbers, meaning there are outliers on the left side. And if you remember, that means it's going to affect the mean. So the mode is our highest number, the median is the middle number, and the mean is going to be our lowest number because the outliers are affecting the mean and pulling it down. In the case of B, this is right skewed. Okay, we have a bunch of numbers in this case on the lower end. The median is there, and then the mean, because we have outliers on the high end, is pulling the mean up a little bit. So if you want, that would be the case of our basketball scores, the 3, 4, 5, and the 40. Okay, we have an outlier on the high end that's pulling up the value, the mean value, not really affecting the mode and the median. And if it is symmetric, the mode, the mean, and the median are all the same. All right, third thing we're looking at is the variation. This is how much the data is spread out. So if we look at A, we have a very tall, narrow peak. That means everything is clustered together. Okay, that would be a low variation. There's not a lot of number difference. Everything's kind of grouped together. B is a little bit lower on the peak, a little bit wider, giving you some moderate variation. And a high variation is a very flat peak. Okay, we got some low numbers, we got some high numbers, so we have a high variation between them. Okay, so let's put all this together. So here are the eruption times for Old Faithful. So I'm close to 40 minutes. So highest one's 110. And I drew a smooth curve to kind of give us a value. I know it's not exactly perfect. Once again, Old Faithful. It's called Old Faithful because our predictable time, but it's not a uniform time. It's not going to follow an exact perfect model. If you actually go there, it gives you the next eruption is approximately, it'll give you a time frame between it. Okay, because once again, real world data doesn't perfectly match mathematical model. So in this case, we have two peaks, one around 50 minutes and one around 80 minutes. It is skewed to the right because I have a value at 100 and another value at 110. Okay, they're kind of much longer than everybody else. Those people are going to have to wait for the next eruption. And it's a high variation. It's fairly spread out over the graph. All right, for this one, we are looking at how long it takes a computer chip to fail. We have a bunch of them that fail within 1 or 2 months, and then we have some that last 10 to 12 months. Okay. This is a one peak. We have one value around 1 to 2 months. It is skewed to the right. Okay, I have just a couple outliers, so it's skewed right. Everything else is well on the left side. And low variation. I have a very narrow high peak between 1 to 2 months, and then everything else is kind of spread out. So one peak, skewed right, low variation. All right. Grades. So one of the things you may have noticed in college is that different classes have different credit hours. In high school, every class had the same value, so you just, if you were trying to find your GPA, you would add them all up, divide by the number of classes, and that was your GPA. In college, you can have classes that are 1 credit hour, 2 credit hours, 3 credit hours, 4 credit hours, 5 credit hours. Okay, the more credit hours, the more influence it has on the GPA. So in this case, we have our student with 14 credit hours for the semester. They took math, 3 credits, got an A-. Religion, 3 credits, got a B+. Spanish, 4 credits with a B-. The astronomy was 3 credits with a B, and the astronomy lab was 1 credit with an A. So when you are trying to find a weighted GPA, what you're going to do is list out the GPA points. So 3.7 for an A-, 3.4 for B+, 2.7 B-, 3 for B, 4 for an A. And then you're going to multiply the credit hours by the grade. So 3 times 3.7 is 11.1, 3 times 3.4 is 10.2, 4 times 2.7 is 10.8, 3 times 3 is 9, 1 times 4 is 4. Add them all up, we get 45.1 credit points, or GPA credits, divided by the 14 that we have for credit hours, and you have a 3.55 weighted GPA. Now, little word of warning. This GPA is going to be a little bit lower than a straight average because this person's lowest grade was in their highest number of credit hours. That would be a 4 credit hours with a B-, Spanish. And their highest credit hours, highest GPA, 4, their A, came with only 1 credit hour. That is not a good way to do it. If you've got to choose between classes, always choose the classes, have some more credit hours. Okay, and kind of comparison. This is the wrong way to do it. Wrong answer, wrong way, do not do this. Just to kind of show you the difference. If all classes were the same, you would just add up the GPA, divide by 5, and you'd have a 3.36 GPA. Okay? That is if they were all worth the same. That is the wrong answer. Do not do that with a weighted GPA. You will get it wrong. But it does show you kind of the difference between it. If they were all the same, it would be 3.36. However, because they got their lowest grade and their most credit hours and their highest grade and their lowest credit hours, it did drop their GPA to 3.32. All right, that is everything you need to know for Section 6A.